So this is the part of my personal project, and where I will be demonstrating the AP properties for Riak database. And yeah, so let me quickly explain through my architecture diagram what I am going to accomplish here as a part of this project. And yeah, so this is basically the architecture diagram for and I have chosen Riak as a database, and the agenda is here to show that Riak is highly available and partition tolerant. So highly available means that even if one of the node dies out, there should be the other nodes in the cluster which are backing up, and so that the user at the so that the end user does not come to know and should be agnostic of the fact that there is any node down. So that is what high availability means, and the partition tolerance basically caters to if there is a network failure, and if like nodes are unable to communicate with each other. So at that time also, DB should be tolerant enough, to take the user request. And since Riak has this configuration set up that the last write wins, so it will allow the user to write in the multiple partitions. But at the end, when the network comes alive, both the partition will come in sync, and the last written portion on the DB will be synced across all the nodes. So here basically the last write wins. So this is the property of Riak DB. So yeah, so this is the partition. This ensures that the Riak is partition tolerant and allows the user to write the DB even in terms if there is a issue in the network and network gets bifurcated. So let's quickly, I will show you how I have done the AWS setup. So I have already opened the tabs. So as you can see, as per the requirement in the project, we have to set 5 Riak clusters. So I have initialized them with the names Riak 1, Riak 2, Riak 3, Riak 4, and Riak 5. And let me quickly show you with the DB also here with my diagram. So I think this should be pretty much visible. So basically I have kept like Riak 1, 2, and 3 in the one security group, and everyone has a different availability region like US East 1B, 1A, and 1F, and Riak 1 is the coordinator node. So basically uh, we have joined all other 4 Riak nodes to this particular node, hence thereby making it as a coordinator node. So that is the one thing, and I have kept Riak 4 and 5 in a different security group, ISG2, and which you will come to know about in later, like how I will show the partition tolerant for these DBs. So yeah, so this is pretty much the architecture, and later as a part of the hackathon project I also introduced ELB, but will not be covering here. So ELB basically will round robin the request from the end user, and it will take care of those functionalities. So these are hosted in one VPC and under the AWS US East region, North Virginia. And yeah, so basically this is the architecture at a high level. So let me quickly, as you all know that there are 2 ISGs. So first of all, I will focus on the term of highly availability of Riak database. So as you can see, all the nodes are running, and let me quickly show you the ISG's part also. So Riak 1 is in ISG 1, and let's untick this, and let's, as we know that Riak 4 and 5 are in different security groups, so I will go to Riak 5, and I will, as you can see, it is ISD 2, and I will open in the separate tab. And as you can see, so basically these are the inbound rules which I have set, and you can see they can basically communicate, and these are the Erlang distribution ports which has been opened so that the cluster can communicate within each other. So yeah, so it is presently open to so that they can have a communication, and I will do a cancel, and in a similar way, if you will see in ISG2 also, there is a similar setup, and you can see the Erlang distribution ports has been set, and the normal usual ports 8098, there would be one port 8098, yeah. So this is the HTTP port, and basically to hit the Riak front end. So anyways, so that will not be covering in the part of the personal project. And so yeah, basically this is the high level ISG. Why I showed you the ISG in the beginning, because I'll be making the changes when we'll be checking the partition tolerant of the system. So as I told, I stressed upon the Erlang distribution ports. I'll be making changes there in order to show how the React is partition tolerant. Without further ado, let's quickly jump into the availability of the React and see how it is available if we make a node 1 or 2 down. So first of all, as a part of availability, we have to send some data, and we'll be achieve this by doing a curl. And as a part of test data, I'll be using two images. One would be of myself, and the second would be of Sir Albert Einstein. And so first of all, I will be pushing the image from my local host to the React buckets named as image, which will be stored as a form of object there. And wait, let me quickly show you. I have opened the commands so that time does not get wasted in the meanwhile. So yeah, so this command, so I have a Sir Albert's photo on my desktop, and what I'll be doing, I'll do a curl. So let me open my terminal, and yeah, so I can check my present working directory is desktop. So we should ensure that we are in the same working directory where the image belongs, and we'll fire up this curl command, which will write image as a form of object in the DB. And yeah, so then we can see the changes there. Where is my file? Okay, here we go. So so I will, as we can see, this is the IP of my AWS instance. Let's quickly check which React it is. So I will go to my EC2 dashboard and into EC2 instances, and oh voila, so basically it's React 5. We didn't have to hop through down. So I think, yeah, let me do, yeah, 122 34.234 to 55 122. Yeah, it's the same IP, and it is React 5, and it is in ISG2. So nevertheless, leave ISG2 as of now, since we are checking availability. So yeah, so we'll fire this curl command. Let me quickly fire this command. So it should create a bucket and write the data there. So I will copy this. So basically this is a curl command, and it is putting the data there in the bucket. So I will fire this command, and yeah, so the command completed successfully. And now let's access this image by checking the through HTTP port. So yeah, so what I have done, I have wrote the name in the name of one.jpg. So in that fashion, I will try to access this. This is the IP, then this is the React DB, and this is the bucket, and this is the object. So image is the bucket, and one.jpg is the object. So we'll go quickly in the browser, and we'll run this command. We have the correct port EC2 instance. So nevertheless, it should be reflected in 5 because they are all connected. So let's fire this command. Okay, we can see Sir Albert Einstein thinking deeply. Yeah, so there is now let's try another server so that we can see that data has been copied in all the clusters. So let's try this 195. I will quickly show in the EC2 instance, which this instance, I think what I remember, it's React 1. Yeah, so you can see guys, like 18.205.96.195. Yeah, and this is the port which I already mentioned while doing a HTTP. We will hit this port. So yeah, so let's go here and fire this command and see if Sir Albert Einstein is there. Here he is. Yeah. So our real so data has been distributed in the ports. Let's for namesake, let's try for one quick quickly another IP, and I will take React 2, let's say random, and I won't show for all five. So by 3 we can establish that yeah, we have data in all the nodes. Okay, so I will quickly write down the command, and I will just this person, and I will fire up this command, and yes, we can see it. And I think let's have a for this. Let's copy this, and we will just change the image, IP name, and yeah, here he is. For React 3 also he's here. And what we are left with, let's do 4 also, come on. Yeah, so we'll go here, copy this, change the IP, and fire it. Here he is. So we can see that data is available in all the 5 nodes. That's what was intended. Now what we'll do, I will bring down one node. So as a part of this, what can we do to bring down the node? So I will, so yeah, so I can bring down the node by, huh, yeah. So sorry, I got confused a bit. I was distracted by thing. Yeah. So anyways, yeah, I will bring down the node by there is an alternate. Either I should bring down my one of the nodes from here, or we can stop the React service. So I will go by the former way, because stopping and starting may take a while, and I'll have to break the video. So in order to avoid, sorry. So in order to avoid that, I will just stop the React service on one of the DB. So let's see, we okay, one is selected, what is the IP, 195. So we'll stop the let's bash into it, and okay, so here we are already. So I was testing this while before making this video. So what I will do is React is already started. I will do sudo React, and I will do stop. So it should stop the service. Okay, so it's mentioned as okay, and yeah, it is done. I think if we'll hit on this particular node, it should not show anything. So because this bucket is not accessible, so 195 where it is, yeah, so this is the node, and I will do a refresh. Yeah, so we can see that site cannot be reached because we are unable to access the data which was written in reactdb, and React is not running. So while now we'll check in the other nodes. So let's say 122. So if I'll do refresh, you can see, yeah, so there is a flicker again. So we can see Sir Albert is visible. And what does this tell? This tells that our ReactDB is highly available despite of one node being down. So end user is unaware of the fact that how many nodes are down in the network, but still he is able to view his or her services. Let's go into another IP which is in the same cluster, and we'll do command R. Yeah, so Sir Albert is still there. So he's not only available in the node where I did React stop. So what I will do, I will quickly make up the service. So I will do sudo React start, and let's see if it is available again. So let's suppose there was some maintenance, and the server was up now. Now let's try to refresh it. Voila. So yeah, so we can see Sir Albert's pick here. And yeah, so what we concluded here is that the React is highly available. So since video is getting too long, I will quickly switch to the partition tolerant thing. So as earlier I mentioned that I have hosted the 2 nodes in different ISG and 3 nodes in a different ISG. So as part of the architecture, let me quickly bring this. So what I will do is the subnet associated with these two. So as I told that there is a long distribution ports which facilitate this communication between the React nodes. So what I will do, I will restrict them to their own subnets. So what I will do is, so that there two different network partitions could be created. So these two, so and they will communicate, the nodes within themselves will communicate within each other, not the other way around, that they are communicating to others, because we will restrict the subnet IP, so that CIDR blocks within themselves. So what I will do, I will go to security groups, which I have opened here, and I will go to edit, and I have already have these subnets associated with these. So what was this quickly? So this is ISG1. Okay, so ISG1, so there are three Riak clusters here. So I will put the respective IP so that they can be limited within themselves. So what I will do is, I will change this, and I will, these are the basically subnets. So I have grabbed it so that we don't have to go here and there again during the video. So yeah, so I will, these are the subnets basically, and CIADR blocks which are associated to each Reacts, and now I will save this configuration so that they are limited to themselves, and this is the Erlang distribution ports for which we are making the changes. So we'll do the similar way for ISG2, and take this and edit this, so that they are also not open to and these are the ports for them. And okay, I will cancel this, and I will make this here, and I will save this. Okay, so I think let's quickly see it. Yeah, they are restricted to them, their partition has been created at one end, and I'm in the network partition. So yeah, so they are communicating within themselves, within their own. So basically two partitions we have created, and now what we'll do, let's see if they are accessible. So yeah, they are accessible. We are doing a refresh, and I will go to here, and what I will do is, uh, React service is running everywhere. What I will do is, I will quickly go, and I will run this command basically. I will try to write the data. Okay, and yeah, so I will write myself. So I have an image here. Wait. So this is my image, and I will try to write that image in one of the cluster, and it should not reflect in the different ISG. So basically it is 195. So what I am doing is, I'm going to this particular React 1 ISG1, which is hosted on ISG1, and I will write this particular image there. So I will copy this, and you can see it is 195, and I'm writing this different image, and I will go into the terminal and desktop, write this image. Okay, so this being done, so in 195 and 195 and associated cluster, I should see myself as an image there. So so this is 122 basically, and 195. So yeah, so you can see basically my image has been reflected, and if I check in the other, like 122, which is hosted in basically, which is hosted in 122, let me quickly show you. So it was React 5th, and 122 is in ISG2. So here you can see Sir Albert Einstein has been not replaced by me. So it shows that though there is a network partition, but still DBs are accessible. It's not that there is a network failure and DBs are not accessible, though data could be different. And as I told, the last write will win. So as you can see in the another node, 191, so you can see Albert Einstein, Sir Albert Einstein is there, and in 191 it should be React 4. Yeah, so because it is in ISG2, and we have pushed the changes in security group 1. So in React, like if we will test in React 3, and what is the IP, so we will see that my photo should be there. Yep. So yeah, so basically it's working. So everything is in sync, and within the partition, and so now as a last step, I will quickly change the security changes and see if last write will win. So guys, please note that the last write was mine image, not the Sir Herbert's image. So what it should do, I mean, when I will make the network back again, I mean pair both of them, so it should open the ports basically, what I meant to say. So it should reflect my image in all the nodes. Though I will not do any post this time or put this time in the bucket. So let's quickly do that. Sorry. I will go to quickly to ISGs, and I will go to ISG1. I will edit it, and basically I will remove this, and I will anywhere and save it. And I will quickly go to ISG2 and I will do an edit, and I will change the underlying distribution. It should be accessible, and yes. So let's quickly, I think it would be done, I'm hoping. And let's refresh it, so it should get replaced, guys. So it should get replaced by image, mine image. So last write wins basically. So I will do a refresh. I save the changes, edit. Yep, changes has been saved. And ISG1, edit, changes has been saved. I think they are pretty much okay. So yeah. Oh, so it takes some time, I guess. So yeah, so might be due to latency. I didn't did anything in the between. You guys probably would have noticed. I just checked the security groups are there or not. Well, so see, you can see the changes are reflected in all the nodes across. You can see here also it has been reflected. If you want to check, like React to some random, and I will quickly just so, and I will wind up after this, and you can see. So here we go. So as a part of this demo, we have demonstrated that React is highly available and partition tolerant. So this is what was the intention of this demo, in order to show that React is highly available and partition tolerant. So have a good day, guys, and hopefully this video helped you out in some way or the another in understanding React and how to check the availability and partition theorem as per the CAP theorem. And yeah, so thank you for watching. Hope yeah, this is a 22 minutes video, and yeah, thank you guys. I won't waste much of the time. Have a great day. Bye bye.